Imagine there is a silica flint glass. When there is a visible light beam incident from air into the glass, the light beam will be refracted. Before we continue, there is one important concept we have to know. Different color have different wavelength. In the visible light, red light has the longest wavelength, which is around 650 nanometer. For the violet light, it has the shortest wavelength, which is around 400 nanometer. The longer the wavelength, the smaller refraction index. Therefore, red light has smaller refraction index than violet light, which implies that the violet light will bend more than the red light. Now, we back to the question. The question has given that the index of refraction for violet light in silica flint glass is 1.66, and that for red light is 1.62. When the visible light ray incidents on the glass, since different color has different wavelength, they will bend with different angle and diversion is happened. The red light bent the least and the violet light bent the most. Now, the question is, what is the angular spread of visible light passing through the prism of apex angle 60 degree, if the angle of incident is 50 degree? The angular spread can be considered as the angle between the refracted red light beam and refracted violet light beam. Let's start the solution with this part first. When the light beam incident on the glass, the red and the violet light ray bent with different angle. For the red light, let the theta red 1 be the refracted angle of red light. Using Snell's law, n1 sin theta 1 is equal to n2 sin theta 2, after some calculation, we can find that the theta red 1 is 28.22. Then, for the violet light, let the refracted angle of violet light be the theta violet 1. Using Snell's law again, we can find out that the theta violet 1 is 27.48 degree. When the red light ray and violet light ray has reached to the boundary of the glass, they will incident with angle, theta red 2, and theta violet 2 respectively. Since the apex angle is 60 degree, then we know that the theta red 1 plus theta red 2 will be equal to apex angle, which is 680 degree. Therefore, 28.22 plus theta red 2 is equal to 60 degree. Then, theta red 2 will be equal to 31.78 degree. Same method for the violet light. Theta violet 1 plus theta violet 2 is equal to apex angle, which is 680 degree. Then, 27.48 plus theta violet 2 is equal to 60 degree. Therefore, theta violet 2 is equal to 32.52 degree. Finally, both of the two light will refract out. However, they will refract with different angle. For the red light, we can let theta red 3 be the final refracted angle. By Snell's law, 1.62 times the sine 31.78 is equal to 1 times sine theta red 3. Then, we can obtain that theta red 3 is equal to 58.56 degree. For the violet light, we has the same method to solve it. Let theta violet 3 be the final refracted angle of the violet light ray. By Snell's law, 1.66 times the sine 32.52 is equal to 1 times sine theta violet 3. Finally, the theta violet 3 is equal to 63.17 degree. Finally, we know the final refracted angle of red light and violet light. The angular dispersion is the difference of the two angle, which means it is theta violet 3 minus theta red 3, and the answer is 63.17 minus 58.56, that is 4.61 degree.